Good morning to all. Good morning to all. Welcome to embedded class. In the last class, we were discussing about the computational models in embedded systems, where this computation model. Okay, let me share my screen here. Okay, we started with actually the hardware software co-design and why it is required, and we get to know that there will be a lack of interaction between the software engineer team and the hardware engineer team, and in turns like increase in the market competition and time to market makes us to go in hand, so which we try to develop a computation models and in order to develop this computation models, like we have a different modeling techniques like data flow graph model, state machine model, concurrent process and sequential process model, and object oriented model, and so on. Now, so these are actually steps. So these are actually the different techniques where I can model my problem statement. Given any problem statement, I take the approach of either data flow graph model or state flow graph. Then probably I decide whether to go with a concurrent process or a sequential process. We'll see the few of the examples in this class, like how we try to model the data flow graph, then followed by conditional data flow graph, then different state machine flow graph. Any problem statement given, we need to analyze the problem statement, and then we are supposed to build the state machine model or data flow graph model. Once we have that model, then later on it is very easy for us to put it in the form of programming model. That in that cases, we took a simple example of computation, like with two inputs of A and B, making an addition of by and giving it to output variable X, and then once again this is Y is depending upon the value of X. Unless and until you get the X value, you cannot go proceed with the further, and then Y equal to X minus C. And we also understood how the data flow graph looks for this particular example. In the last class, we studied this. Then now it is very easy to translate this data flow graph into either sequential programming model by using C programming or C++ programming, or else even you can allot this, you can go for using Verilog coding. Now, the second type of programming model that we have here is the control data flow graph, or in simple we call it as CDFG. This is once again a data driven model, which means that the model is depending upon the data. Based on the data, I go on modeling my flow graph. So mainly this particular programming model or DFG model involves a conditional program execution, which means I consider or I go for executing some actions based upon the conditions, conditional programming. So we'll take one of the example, like how CDFG can be implemented by taking some condition here. So assume you need to perform y equal to a plus b or a minus b based upon the flag appearance. If flag is 1, if flag is equal to 1, then I go for addition of two inputs, else subtraction. Now, how do you translate this to CDFG? So these concepts you might have learned very well in your C programming in the form of flow chart, but probably you are not knowing that this is called as data flow graph. That's it. Okay. In that perspective, once again we try to develop a conditional flow graph and you know that how to write it in the as a conditional flow graph in a diagram or pictorial representation or a flow graph representation where we use a rhombus symbol. Now, if flag is equal to 1, there might be two possibilities. One is true or another one is false condition. Now, if it is true, then what operation I should perform? I should apply A and B. Now I consider two inputs, A and B, and I go for adding up of those two inputs. Then once again, if this is true, then
Excuse me, sir.
yes.